Hey everyone, my name is Vinelin, and in this video you're going to learn how you can use the new DeepSeek-R1 distill model on a local instance and chat with your local files. We're going to be using an Nvidia's earnings PDF file on which we're going to be asking different questions, and the model will extract some financial information about the document for us. We're going to be using a local Ollama instance with the model running on it, and we're going to be using a roughly 10 pages of a PDF file. Let's get started. If you want to become better AI engineer, you can subscribe to ML Expert Pro. Here you can find a complete AI engineering bootcamp with starting the basics of Python, PyTorch, statistics, and classical machine learning, up to building agentic systems, RAGs, CAGs, and agentic workflows. Here also you can find information about how you can fine-tune your own LLMs, and all of the available source code that I'm showing throughout these videos is available for ML Expert Pro subscribers. So if you want to become a better AI engineer, go and subscribe today. Thank you. The model that we're going to be using is the DeepSeek-R1 model available in the Ollama library. Here you can see that this model was actually updated about 10 hours ago, and this model is based on the architecture of Qwen 3, as I have already told you, and the total size of the model is 5.2 gigabytes, and you can run the Ollama run DeepSeek-R1 8B command in order to get this model. Most of the other models are actually not distilled versions of the upgraded DeepSeek-R1. Only I believe this one is the one that is using the Qwen 3 and the latest version of the model. Once you got the model downloaded on your machine, you can start your Ollama instance and then run Ollama run DeepSeek-R1 8 billion parameter models. And here, if you start with this, you see that the newly updated version of the Ollama, which is 0.9, is first starting with the thinking, at least for this model, since this one supports it, and then you're getting the response in a different font color, as you can see here. So this is a nice way to check whether or not you have the correct Ollama version and the latest version of the DeepSeek-R1 distill model. The PDF that I'm going to be using is going to be the Nvidia financial results for first quarter of the fiscal 2026 year. You can note here that this is a very new file, so this wasn't in the training data of the distill version of the DeepSeek-R1 model. And you can see here that this is actually quite a dense information, and it contains a lot of tables. The earnings report is provided in a PDF format by Nvidia, and you can note that this is actually a 10-page file. Again, this pretty much contains all the information that we've seen on the webpage, along with pretty much a bit more tables and more information with that. One thing that I have used in order to convert this PDF into a markdown file that we're going to be using for our chat with the document is going to be Ollama parse. In my case, I have used it in order to convert this text and tables into a markdown format so we can work with the LM. Of course, if you want to be using something that is free and open source, you can start with Docklink. I have a video on how you can run such a pipeline, but in this case, I wanted to get something quickly converted into a markdown file with a relatively high accuracy. This is my Visual Studio Code, and in here you can see that I have a Jupyter notebook already open. I also have the markdown file that is extracted from the PDF that I've just shown you. And here you can see that actually Ollama parse did a great job on how to extract the tables. I've looked through some of the text and it appears to be extracted very nicely. Of course, this is a very high quality PDF file. It is very nicely digitized, if you will. So based on that, we got this relatively good markdown output from the PDF. Of course, this will be helpful for us once we start analyzing the information for it. So in the latest version of the Ollama library, you are going to be able to toggle the thinking of the models and take the thinking output as well. So I'm going to be using that as our only library that we're going to be using for this notebook. And then I'm going to be downloading the data file, which is going to be this markdown that I've just shown you. So to set up everything, I'm going to be using the DeepSeek-R1 8 billion parameter model that I've just shown you. And the guys from Onslaught actually provided the recommended settings for this particular model. I'm using a 0.6 as a temperature and then a top P sampling as 0.95. So this will be essentially our sampling parameters. And I'm also going to be increasing the context window, which currently in Ollama is 4096. And I'm going to be doubling down this, since the file itself will take roughly between 2 and 4,000 tokens. So I'm going to be increasing that in order to get a relatively nice outputs. Of course, the DeepSeek-R1 model is a thinking model in general, that is, and those tokens are going to be also added to the overall output tokens that you're going to be asking the questions about. And I'm increasing the context window based on that. Also, I'm going to be reading the whole markdown file into a variable called Nvidia earnings, and this is going to be presenting the first 1,000 characters in here. Again, this is roughly this file that I've shown you right here. Just worded as a string. Of course, note that this is a relatively large file, and I really wanted to test how good the model is going to be in non-RAC environment or in a CAC environment, where I'm going to be presenting the whole document that I'm interested in and then start asking questions about it. So the setup for the calling of the model is relatively simple. I'm going to be using the Ollama.generate method. Here, the more important stuff compared to previous video that I've shown you is this our think parameter. I'm going to be renaming this to our thinking. By default, I will want the model to actually reason or think before answering. And then you can see the parameters for the sampling and the context window increase with the num context or CTX parameter right here. In this case, I'm going to be only using a text as an output. So this will actually not be needed, but if you want to force the model to be using JSON, using, for example, pedantic objects, you can further customize this or extend it in order to do that. So I've shown you the hello in the terminal, and here I'm pretty much doing the same thing. I also have this helper function, which is going to be printing the text a bit more nicely. So here you can see that now the Ollama API supports .thinking on the response, and this essentially is going to be the thinking string or the thinking text that the model is going to be returning for us. And then the dot response is actually going to be the text that you are more likely to present to the user as a final response. So I've talked about that you can actually disable or disable this thinking process. And if I do the same call here with our thinking equal to false, you see that the response time is roughly 6 times faster compared to the it's even more. It's actually like 8 to 10 times faster compared to this 18 seconds. Yeah, let's make 18 seconds or something like that. And here we have just a wall time of 2.2 seconds roughly. And you can see here that we have no thinking string, and this is the response. This time the response is actually quite a bit longer compared to the previous one. But of course, this might be just to the case that we're not using thinking, or maybe the temperature is allowing us to get slightly different strings as an output. So let's continue with the analysis of the financial document. That is something that we are truly interested in. And here you can see that I have structured this prompt using the better or new prompting rules that we have. I have read somewhere on Reddit that most of the training data for the new DeepSeek-R1 model is actually using Google Gemini instead of OpenAI's ChatGPT models. I'm not really sure if this is truly the case, but even if it is not, these are the structures of the prompts that pretty much Anthropic, OpenAI, and Google are converging on. So you will note here that I'm giving it a role first. You're an expert financial analyst. You're analyzing financial reports and earnings calls. Your goal is to accurately answer questions about the document using the information provided in the text. Then I'm giving it a list of instructions into an XML format. Carefully consider the complete content of the document. I don't want these models to be essentially going through the first information possible, extracting it, and answering based only on that. I would like to get a more holistic approach, if you will, provide answers in a concise and clear manner. Most of those models are essentially providing a lot more text that you might want to read through. So I want a concise and clear responses, and give contextual information when necessary, but avoid unnecessary details. Of course, this is quite, let's say, abstract instruction, but in some cases it appears to be doing wonders for the responses. So next I'm providing guidance to the output format, and I want in this case to have markdown always as an output. And you can also go for a structured output, but I haven't currently tried the structured output with Ollama using this model. It might work great. You can try it out on your own. Do let me know in the comments below if this is actually that is working quite good with this model. And this is where I'm going to be passing in the document text. Next, I'm going to be passing the question that is going to be coming from the user. And then again, I'm also repeating the more important instructions. Answer the question in Markdown format. If the answer is not available, state that the information is not available in the document. Of course, such small models, such as this distill version of Qwen would probably have relatively high hallucination rates. I would guess that just based on their size. But of course, more evaluations need to be done in order to know this for sure. And then you actually prompt the model to give you an answer after this. I'm essentially removing the white spaces around this prompt and stripping all of the characters that might be added by a mistake. So the first task that I'm going to give to this model is to provide me with a summary of the earnings call, including key financial metrics and any significant developments mentioned. So this is more of a free form prompt. And based on that, you see that actually this took roughly a minute and 40 seconds on my M3 Pro base machine. So it was quite a lengthy time in order to get a response. You see here first that this is actually a quite long thinking process. If I expand this, you see that internally during the thinking, it provided a short summary of these 10 pages. Of course, this needs to warm up the KV caches of Ollama in order to start and understand the complete document. And this is the response. I have just copied and pasted this into a markdown format. So essentially what I have asked here is for a summarized report on this PDF file. And here it says that Nvidia reported strong first quarter financial results for the fiscal year of 2026, driven by continued growth in its data center segment. Key highlights include revenue, and this revenue is actually correct, representing a 12% quarter-over-quarter increase and a significant 69% year-over-year jump. I think that this number is also correct. Data center revenue is 39.1 billion, the largest growth driver for this quarter. I really like that the model started with pretty much the most important information, whether or not actually Nvidia is making profits and whether or not these profits are actually increased or does the company have a growth? Since if you're a financial analyst, you probably be more interested in this than any other numbers within this PDF. Of course, you can see that it got a list of notable developments, the launch of Blackwell, which of course is very important, major partnerships such as with Humane in Saudi Arabia, G42, Oracle, etc. This is amazing for such a small model. This is still a 8 billion quantized model, and all this makes sense, and all of this is actually pretty correct factually. Of course, you can go through the PDF on your own and maybe fact check all the information here. But what I'm more interested in is whether or not this model is going to be able to extract specific information that one might find interesting. So I am going to start or continue with the extraction of the information with profits and losses analysis. And here the prompt is relatively simple: extract profits and losses summary for the Q1 of the fiscal 2026 in the GAAP format. So here I have revenue, gross margin, operating income, net income, and diluted earnings per share. So I'm again giving the complete text information. All of these are actually available within the tables of the markdown file that I'm going to be using. And you can see first here that this took roughly 50 seconds. So this is more or less 2 times faster compared to the whole summary. You can see the whole thinking process right here. This is quite a long thinking process. But for the actual response, you can see that I just copied this again. You can actually see that it got just a title based on the provided document. These are the numbers. The information is explicitly stated in the earnings call transcript and financial tables provided within the document. And this is completely correct. Again, I'm pretty much blown away by the performance of this model. It is quite good, at least thus far that is. So I have actually used Gemini 2.5 Pro with the complete document again, and these are the numbers that it got extracted for me. So you can see that we got a 100% match between these two. Of course, there are some roundings here and there, but pretty much 100% equality between the Gemini 2.5, the PDF that I have manually checked, and DeepSeek-R1 distill model. So the next thing that I want to ask the model or extract information for is the actual balance sheet. Again, within the same format, the same year, I want cash equivalents, and marketable securities, inventories, accounts receivable, in net, total liabilities, and total shareholders' equity. So here I roughly get another small increase within the waiting time, and note that each of those queries are actually independent, so I'm not storing the conversation. This will probably be available within some of the next videos that we're going to do. And the thinking again is relatively nicely formatted. You can go through this on your own, but I'm more interested into the response, and here I just copied and pasted this. So again, I have checked these numbers, and again, those numbers are pretty much exactly the same as what we have from Gemini 2.5 Pro. You can check some of the results here. These cash equivalents and marketable securities, inventories 11,333 million. We got accounts receivable net. Here we have another subheading or heading with total liabilities. Those are again correct. And then here we have shareholder equity. I have again checked this number within the PDF, and yeah, I can see all of those numbers exactly the same. So again, perfect score. Of course, still extracted from markdown tables, but this is a 10-page financial document running on 8 billion parameter quantized local model. So quite good actually. And the final section that I'm more interested in is the cash flow statement. So here you get a lot of information, again, within roughly the same tables. We have net cash provided by operating activities, free cash flow, purchases of property and equipment, payments related to purchases of common stock, cash and cash equivalents at end of period. So again, this is the cash flow statement, and this is within a table. These took roughly a minute to complete, a bit slower since probably my guess is that the information here was pretty much more within the some parts of the later stages of the document. And here you can see that the thinking process was actually quite a bit longer or more dense, and the response itself is another table. And here let's see whether or not this was actually again a correct answer or not. On the bottom, the correct values that were also given by Gemini 2.5 Pro. The net cash provided by operating activities is exactly the same. You can see that actually the model has set here in millions, which is correct. And this free cash flow is again a correct number. The purchases related to property and equipment is again exactly correct. Here we have some of those brackets, not really sure why the model has provided those, but yeah, still a correct number. Payments related to purchases of common stock, again, exactly correct number. And then cash equivalents at end of period, again, exactly a correct number. Here I have also a reference to the Onslaught guide on the correct parameters for running this Woko model. And I would say that even on the worst one, we got a perfectly correct response. Of course, it might be the case that this is too easy of a document to work with, but thus far, at least on models before Qwen 3, none of those models were actually able to run this type of analysis. Anything below, let's say, 24 or 30 billion parameter models. So this is pretty great for 8 billion parameter model. So this is it for this video. We've seen that the distill version of the DeepSeek-R1 model with a base of Qwen 3 is actually extremely good for 8 billion parameter model running entirely locally on my Ollama instance. The extractions and the summaries are with the correct numbers compared to even Gemini 2.5 Pro, and the real values are pretty good. I'm honestly very happy with the results, and this is probably the first model that is of course within this range of 8 billion parameter models that is so good in order to extract some of this relatively complex information within the tables and understanding of those financial documents. Of course, it might be the case that this is just a too easy document to extract some information from, but even if this is the case, I'm still quite happy with the performance of the model. Unfortunately for us, at least as of now, the DeepSeek-R1 8 billion parameter model is not marked with tool support within Ollama, so you can't really use it as an agentic model. There is an issue on GitHub that is going to be hopefully addressed, and we'll be able to use this model as a tool calling model as well. This would be great since you can now also disable the thinking and probably get much better tool calling compared to previous models, since this was one of the selling point or feature improvements provided by the DeepSeek team. Thank you for watching, guys. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description of this video. Go and subscribe to MLXpert Pro to become a better AI engineer today. You're going to be able to access all of the content that I'm releasing to members, along with all of the source code and the projects that I'm sharing with the MLXpert Pro subscribers. Again, thank you for watching, and I'll see you in the next one. Bye.